Good morning, good afternoon, and good evening. Welcome to the Adopting GitHub Actions at Scale in the Enterprise office hours. If this is the first time you join us, allow me to introduce myself. My name is Bassem Draidi, and I'm a senior solution architect, part of the expert services team. My team and I work with enterprises and corporations across the globe to solve a variety of different technical problems. One such problem is figuring out how to scale GitHub Actions within the enterprise. This series was composed of 4 events. During these events, we were going to be tackling these questions of how can we deploy and auto-scale self-hosted runners? Can we use Kubernetes for those? How can we manage our access to self-hosted runners? We've gone through a big part of these or answering these questions in episode 1 and 2. I'm going to tell you where we are right now in this series. And we're going to be answering so much more technical questions and inquiries and implementation details in these sessions. Episode 1, we basically set up Kubernetes and we use AKS for that. This is where we were going to be hosting our self-hosted runner setup. In episode 2, I showed you how you can install Actions Runner Controller on AKS and how we can use it with webhooks and GitHub apps and TLS termination, to scale up and down our self-hosted runners to meet the demand of our workflows. And in this episode, I'm going to be showing you a lot more of more advanced best practices so that you can tighten, harden, and secure your environment while also customizing it for more specific needs that you might have. Previously, we had planned for this event to be 4 parts. And episode 4 was about me showing you how you can create a custom scaling solution for your setup. However, we thought that it might be better if we gather your feedback first and listen to you and understand what are the different types of problems that you might be facing. And then we can design an episode that will basically answer these specific problems as opposed to us coming up with what we think your problems are and giving you hypothetical solutions for them. So we would love to hear from you. Please make sure that you reach out to us and tell us what you would like to see in the 4th episode, and we will make sure that you have that and prepare it for you. Today, we're going to be talking about the advanced best practices, and we're going to be covering, first of all, how do we set up and configure our WAF, Web Application Firewall. One of the main reasons why we adopted the application gateway is our ability to have a WAF in front of our webhook endpoint. And the WAF will basically allow us to protect against a wide variety of malicious attacks that could, hit our internet-facing webhooks endpoint. This is very important for enterprises, and it's way more important if we are exposing this endpoint from our Kubernetes cluster. So today I'm going to be showing you how you can protect that. The second thing is I'm going to be showing you how you can install multiple action runner controllers in multiple namespaces, because within enterprise environments, we want to create isolation sometimes in between teams and isolation between self-hosted runners. This is a very critical requirement for a lot of corporations out there, especially the ones that are more regulated than the others. And you also want to guarantee that if you have a compromised runner, that doesn't, lead to compromising the entire cluster or the array of runners that are, in different areas. So namespaces will guarantee this separation and they will guarantee this isolation. I'm going to show you today how we can leverage that for more security. Next is we're going to talk about Docker in Docker and how we can use that, because right now our self-hosted runners cannot run Docker-based workflows. So if you have a Docker build, Docker push, Docker whatever, inside your workflow, they will fail because our runners do not have Docker equipped in them. I'm going to show you how you can enable Docker in Docker so that we can use containers in our workflows. And lastly, I'm going to show you how you can create your own custom runner image, because obviously you might want to install your own certificate bundles. You might want to install tools or compilers or let's say keys or secrets or whatever on the runners themselves that you want to make available for your teams and workflows. So I'm going to show you how you can customize the default image and how you can embed whatever you need to in that container. And lastly, as we usually do, we're going to end up with a live Q&A where I'm going to be taking your questions live and answering them to the best of my abilities. Now, of course, these sessions are going to be recorded. They're going to be made available on demand. So one more time, just sit back, relax, focus on the content that I'm going to be showing you today. And of course, think about questions that you will be asking me towards the end of this session. As usual, we start with the reference architecture before we dig into the implementation details, and allow me to jump to my diagram. This whole setup, we've already configured it. We have it in place, so nothing is going to change to it. What we're going to be doing today is we're going to be basically working on the application gateway to enable the WAF and add the necessary rules for us to protect our, webhook endpoint that is exposed to the internet, right? So we're going to be doing a lot of work on the application gateway level. Next, we have been operating within the boundaries of one namespace in our cluster. And today we're going to be creating another workspace. I'm going to be showing you how you can install the action runner controller in multiple namespaces. There are a few tweaks that we need to do before we are able to do that. And then we're going to be exposing another endpoint through our Ingress controller for the second webhook configuration. And I'm going to be showing you also how you can do the integration with a personal access token as opposed to a GitHub app, which we have used so far. The personal access token will allow us to have runners configured on the enterprise level. And then if you have teams that are spread across multiple organizations that you want to supply the same runners for, you can leverage this mechanism, to set up your self-hosted runners and have them available for teams across organizations without installing multiple GitHub apps on the different organizations and having to manage them. And this is what we're going to be doing today. So we're going to be focusing a lot on our Kubernetes cluster as well as the application gateway to introduce these changes. And without too much talking about the theoretical, let us begin. Let's jump to our browser. And as a quick reminder, there's a repository associated with this video series. You can find it under my GitHub account, link /actions at scale gh office hours. In this repository, you'll find basically all the resources, and you will see here that I have added more resources specifically for this session, and I've updated the folder structure. You can find all the documentation that you need and description of what is contained in every one of them. We are gonna, and of course, the step-by-step instructions for everything that we are doing through the video. It's very important to watch the videos before consuming this repository, just so that you can understand the context and what's really happening with every step of the way. I'm going to be adding at the bottom of this repository a set of resources for additional documentation, more tutorials, more documents that you can read for further configurations, further changes that you might want to introduce down the line, and for troubleshooting. I'm going to be sharing this reference with you so you can come back to it whenever you need to. Now, let us jump to our Azure portal. This is where we left off last time. We had the main resource group, GitHub Actions Runners. In this resource group, we had the public IP, we had the VNet for the application gateway, we had our container registry, our application gateway, as well as our cluster. And we're going to start by enabling the web application firewall on our application gateway. So inside our resource group, we can just click on the application gateway over here, and we're taken to the landing page for this application gateway. And the nice thing about it, I like these visuals because they can show me the different requests that were made, and I can start troubleshooting from here. I'll show you in a little bit how you can have more advanced views for you to understand what's going on a little bit more on the application gateway level, and for you to troubleshoot this at the organization or enterprise level. So first of all, we're going to jump to the web application firewall section on the left-hand side. And you can see here that we have started our application gateway with the standard v2 SKU. We're going to switch the WAF on, and we're going to click on enabling the firewall. Next thing we're going to do is we're going to change the firewall mode from detection to prevention. This will basically block HTTP requests that are malicious or that the web application firewall thinks are malicious, right? This is very important. You need to be aware of the implications of this. So if you enable it in a production environment, please be aware this will block your requests. Exclusions, we're not going to exclude anything. And we're not going to inspect the request body. I'm going to keep it open because also I don't want to specify a body size. This is important because the webhook events might vary in payload size, and they might be either small or big. It really depends on your workflow and what you're trying to do. So I prefer not to inspect the request body so that we don't block, false positives. The next thing we're going to do is we're going to jump to the rules section, and we're going to define the rule set. And you have multiple ones, and these are continuously updated, with more rules to block or more rules to check against. And then if you want to do more advanced configuration like disable certain rules from being enforced, and this is important as you do some trials, back and forth, checking what is really blocking what is creating a lot of false positives versus what is really blocking, security threats. You can enable and disable them on a per item basis. And of course, this probably will enhance the performance of your web application firewall, the less rules it has to check each request against. Now, you can read more in the documentation for Azure about what these rules are, what is the changes between OWASP 3.1, 3.2. There are some changes, but for now, we're just going to stick to this, and I'm going to keep everything to the default. The defaults are quite sensible, and I am going to save my changes right now. It might take a little bit of time for these changes to be applied, but once they are, we will get a notification, and I can show you right away how the web application firewall behaves. Brilliant. You can see here that it has been successfully enabled. If you go to our application, we can see this configuration applied right now. And for us to do a quick sanity check, we can simulate this. We can do a fake SQL injection, for example, on our URL and see if the WAF responds. So I'm going to jump to my terminal so that we can simulate a quick SQL injection attack. And we are going to first pull the application gateway host name, and we are gonna craft our curl command, and we can do that with the following, and we can append a simple simple simulation of a SQL injection. We're gonna encode the single quote with this, and then we're gonna say 141. This should trigger the WAF to block the request. You can see here we receive a 403 forbidden. And for us to verify that this is just not the default behavior, I'm going to make a request to my test app. And as you can see here, because the request is okay, it goes through. I get the proper response that I should be expecting. And this basically means that our web application firewall has been configured properly, and it is preventing or blocking attacks that are malicious. Of course, in addition to the web application firewall, I really like the application gateway because it allows us to have a lot of metrics and information about the requests that are coming in, and it can allow us to measure so many different things. So if you go to your diagnostic settings, you can add a diagnostic setting over here, and you can see I've already added one. And if I click on edit settings, you see that I'm already forwarding all my logs and all the metrics, and I am sending them to the log analytics workspace, basically for storage and for analysis later on. And if I go to, for example, logs, I can run certain queries, for example, to see like the number of requests per hour, or maybe even the failed requests per hour. And then these are some default queries that are granted for you, and then you can also craft your own queries based on different parameters. And here we're just querying for all the HTTP requests that have a response code that is higher than 399, which basically 400 and above. This is pretty cool. I highly recommend that you enable it. You can also configure alerts, of course. So if you, for example, you have different attacks that you want to keep an eye on, you can configure alerts for those, and then you can respond more effectively and block the attackers from moving forward. So this is the second benefit of using the application gateway. We are going to jump right now to talk about a different thing, which is enabling Docker in Docker so that we can use containers in our workflows. And for that, I'm going to jump one more time to my terminal. I'm going to clear my terminal over here, and I want to show you a small, configuration file that I have already prepared for you so that we can enable Docker in Docker. We have already previously, if we basically list the files that we have, you can see in actions runner controller. If we do the following, you will see that we have the autoscale underscore webhook. This is basically what we have deployed right now, or what we have in our default namespace. Let me show you the content of that. Sorry, it's like this, autoscale webhook. And we have just basically deployed the vanilla deployment. We did not really change the spec or the configuration for the runner images. So we are not using Docker in Docker by default. It's disabled by default. In order for us to do that, I have provided you with another configuration, and it's in the same folder, and the file is called dind underscore deployment.yaml. And if we open this one, you will see here that I've added a couple of parameters. One of them is image. So now I am using the image that has Docker in Docker installed and set up. And the second thing, I am enabling the flag Docker within runner container to be true. And I am going to deploy this as a separate deployment. Why? Because I want to give this a new label, and I'm going to give this label Docker. And this is another example of how you can have multiple types of deployments, different runner images, that are scaled differently depending on the needs of your team. So, for example, not all your teams might require Docker in Docker. Then you can create a deployment with a smaller number of replicas, so that you don't needlessly scale Docker in Docker type of containers. So we're going to deploy this very quickly with the following command. So as usual, kubectl apply, and then we provide the file, and then we're going to deploy it to the default namespace. And then, as you can see here, the runner deployments and the horizontal runner scaler have been deployed. And if I do kubectl get pods -n default, I should be able to see here that I have the registration Docker in Docker runner currently being created. And now we have all the building blocks that we need. So I'm going to jump to my browser, and I'm going to go to my inner sanctum organization. And then we're going to jump to the scaling actions test repository. And I have created a new workflow that I've already provided you with the sample workflow in the repository I shared with you a little bit earlier. And it's called Docker job. And as you can see in this workflow, I am using the label Docker. And what I'm doing here is I am asking this workflow to run inside the container, right? Node version 14.5, Alpine, right? Alpine version 3.12. So I'm asking this job to run inside this container. And then the next thing I'm doing is I'm instructing this specific. Sorry, I missed one step. So the first step is I am fetching the operating system release, right, or the container image name or type over here, because I want to guarantee that I'm actually running inside the container and I'm not running, inside some other inside the main Docker container, which is the runner basically. That's why I chose Alpine, because my runners are Ubuntu based and they're not Alpine based. So if this returns Alpine, that means that I am actually running inside a container. And here I am testing another step. I'm trying to run it in another type of container, which this time it's Node version 12. And I really did not specify Alpine. And I want to see also the outcome of the operating system or the version of the container image that I am actually using. So this demonstrates that we are running inside containers and not necessarily within the main runner container. So I'm gonna trigger this job run, and we're gonna see the outcome of that. I'm gonna jump to the Docker job section. I'm gonna click on run job and run workflow. And we're gonna wait for this job to be completed so that we can actually have a look at the outcome. Right now, you can see that this job is running. And if we click on this one, we see that the image is currently being pulled. That's great. That's exactly what we want to see. You can see here that the workflow has completed running. And if we look at the step initialize containers, yeah, there's not much going on here. You can see that the images are pulled successfully. Run inside container. So the first job is running within Alpine Linux, as you can see here. And then use another container. You will see that I am running another container here, and it's running inside a Debian distribution or Debian image. This basically is a quick demonstration of how you can use Docker in Docker to run Docker-based workflows. One thing you need to keep in mind is whenever you use Docker in Docker, the pod will run with, or the container will run with in privileged mode. This means that it is running at root level. This is an acceptable security concern for certain teams or groups, but it is not acceptable for others. You should be aware of this, and please read the Action Runner Controller documentation to learn more about this. At the moment, there is no way around this. I'm afraid you can probably set up Docker rootless, but I'm not sure that you're gonna get all the functionality that you are expecting if you run it that way. So this is the caveat that you just need to keep in mind. Brilliant. The next thing I want to show you is how you can create now your custom, runner image, and how you can install on it certain custom tools, and how you can use that to create a unique deployment with your own, custom runner images. And we're gonna do that by going to my repository here. And I already provided you with a sample Docker file for how you can achieve this. So if you go to the folder custom runners, you will see that we have a Docker file over here. If you click on it, I will show you what's going on. So first of all, we are starting with the base image, the Summerwind Actions runner. You can, of course, download this base image, scan it for vulnerabilities, for issues. You can have a look at the content of this image also, or you can rebuild it yourself. Feel free to take whichever approach you want to take. And in this Docker file, I'm just taking the easy path over here. And then in this Docker file, you can add basically your CA bundle if you're using a custom CA. This is the perfect place to do so. If you have proxy configuration that you want to add, this is probably also a good place to add this proxy configuration. And then what I'm doing here to give you an example that this is a custom runner is that I am installing Go, which doesn't come by default in the Summerwind or in the Action Runner controller base image. I am installing Go version 1.17, and then I will be running a custom workflow to compile a small Go program and run it inside this runner. So this is how the Docker file looks like. What I need to do right now is I need to basically build this image and then push it to ACR and then change my deployment so that it pulls this image or create a new deployment that will utilize this image as opposed to the default runner image. And the way we're going to do this is, one more time, I'm going to jump to my terminal. And because I'm already operating in a container here, I am going to jump to my regular machine because I would like to use Docker. So I'm gonna, first of all, fetch the ACR URL and I'm gonna store it in a variable. Sorry, let me just jump to bash very quickly so that we stay consistent because I personally use another shell. First of all, we're gonna fetch the ACR URL. We can do it with this command, ACR throw, and I've probably used it before. It's very simple. And then the next thing we need to do is we need to log in to our container registry. You can do that with ACR login, and then you provide the name of your container registry, and Azure, Azure CLI will take care of the configuration on your machine. That's great. And for us to do a quick check whether we are authenticated or not, you can have a look at the config.json file inside your .docker folder. And you can see here that I have the GitHub Actions OH ACR entry available, which means that I am properly logged in. And now we are ready to build our Docker file, tag it, and push it to our container registry. So first of all, I just want to do a quick directory check. This looks good. And I want to make sure that I am in the root directory of the repository, that I'm not in some subdirectory, because otherwise the context will fail. And what I'm going to do right here is I'm going to call the docker build command. So I can do it with docker build, and then I'm going to tag it with the URL for ACR. And then I'm going to call this runner image, and I'm going to give it the label, give it the tag go1.17.6. And I'm going to specify the Docker file basically in my sub directory custom runners. Okay, and we're gonna build this image right now. It shouldn't take a long time. I already have this image built, so I have a lot of the layers cached. It will take a little bit more time on your machine. And once you have this image built, now we can push it to ACR by doing docker push. And it might take a little bit of time to push all the different layers. Fantastic. Now that our image has been pushed to our container registry, we can execute the new deployment or the new configuration for this set of runners. And I have already, of course, created the configuration file for you. Let's have a quick look at it. So if we do cat and then the file go-runners-autoscale_webhook.yaml, you can see here that I've configured the image to point to my GitHub Actions ACR, and then the proper image with the proper tag. And I've also provided the image pool policy to be always, because if you're trying to do tests, you would want your runners to be created with the latest image every time. And don't worry, Kubernetes caching capability does not pull the image every single time, right? It just pulls it whenever there's a change. Everything else is pretty much the same. We haven't changed it much, but we have also provided the label go to these specific runners. And we're gonna deploy this right now by again running a kubectl apply dash f. Oops, apologies. I need to run this from my container because I don't have the Kubernetes context configured on my own machine. So again, we're gonna deploy the configuration from here, and we're gonna do it as such. That's great. Quick sanity check, get pods dash n default, and we can see now that we have the Go runners registration container or pod already being created. And now I have created also a sample workflow with which we can use to do a quick test on this. So I'm gonna go to my trusted repository, and then we're gonna jump to actions. I have a custom runner job workflow that I've created. Let's jump to the workflow file very quickly so that we can see what's going on inside of it. And it's called custom runner.yaml. And inside of here, you can see that I've only changed the label that I'm using. And towards the bottom of this file, I am simply compiling, creating a file, which is called hello.go. And I am adding to this file some Go, a small hello world Go program. And then basically I am calling the Go compiler to run this Go code. That's all I'm doing. I'm gonna go to my actions tab, and I'm gonna click on this workflow, and I'm gonna trigger a new workflow run. And I'm going to jump to my workflow to see if it has been dispatched. And as you can see here, a runner has been assigned and our job has been completed successfully. And if you see here, hello world, that means that our workflow has been successful and we were able to utilize our custom runner, to do something that is not available off the shelf. And this is how you can simply create your own custom runner images. And if you have specific builds that you need to run, or you need specific tools, or you might want maybe bigger, runners, or install proxy configuration or custom certificates or whatever you need, this is the way to go. For the last part of our episode, I want to show you how you can create multiple namespaces. And in this case, we're just going to create an extra one in addition to the default namespace. And we're going to install another action runner controller there. And I'm going to show you how you can configure the application gateway. And this is the third nice thing about the application gateway, how you can configure it to point to the webhook, node or runner, or container of the second action runner controller in the secondary namespace. And this will allow us to have two controllers running, managing the self-hosted runners within two distinct and separate and isolated namespaces. And I think this is a pretty much desired functionality that a lot of enterprises or a lot of you would want in your setups. So let's dig right in. I'm gonna jump to my terminal one more time. And first thing we're gonna do is we're gonna create a new namespace. We're gonna call it alt namespace, or alternative namespace, basically. The next thing we're gonna do is we're gonna do some editing to the values.yaml files. And I've created a couple of samples for you, or the samples that you can use. Why? Because I will show you in a little bit when we jump to this configuration file. So let us jump to the actions runner controller multi namespaces underscore values.yaml. And what's going on in this, I'm going to show you a little bit now what's going on in this file. So I'm going to open it, and I will actually, let me make this a little bit more distinctive by using vimdiff. And I'm going to open this one, and I'm going to compare it to the values.yaml file that we have created the first action runner controller in the default namespace with. And it's going to show you basically the changes that I have introduced to make sure that we are, multi-namespace compatible. So the first thing that we are going to introduce as a change is, you can see here on this side, the name override. So the name override is the first thing we're going to change, and you need to append a value to this. So when you install your action runner controller in a specific namespace, you need to put a value for this name override. Otherwise, your controllers, if you install them, they're either the installation is going to fail or they're going to misbehave because they will clash in terms of resources. So the name override will guarantee that we have a unique name for the resources that we're going to be creating. And I'm gonna call this one. I'm gonna give it the name of my namespace. It's gonna be default, and then the full name override is gonna be default dash actions dash runner dash controller, and that's it. That's all you gotta do in this section. And then in the scope section, you will need to change the single namespace value. And you can see here that I've edited the single namespace value to be true, because this means that the action runner controller will only listen to events in this particular, or will only listen to events and create runners in this particular namespace, and it will not take cover any other namespaces. And then the second thing we're going to specify is the watch namespace. And here we are saying that this controller manages and creates runners and listens to events in the default namespace and no other namespace. These are the second changes that you need to introduce in the scope section. And the third change you need to introduce is in the GitHub webhook server section, which is also introducing the name overrides. So same as we did before, just introduce the default name override, and in the full name override, you can give it the name default dash GitHub dash webhook server. Of course, you can configure these names to whatever you like, but these are basically the only changes that you need to introduce. And as you can see, there are no other diffs between these files. Everything else is pretty much the same. So I'm gonna close this. And what we're gonna do right now is we're gonna update our Helm installation of the Action Runner controller with the multi-namespace configuration. And we're gonna do that with the following. So Helm upgrade dash dash install, and then we're gonna specify the default namespace, and the file that you're providing this time is the multi-namespace values.yaml instead of the values.yaml. Please make sure that you also make sure that your GitHub app private key is properly configured, along with all the configuration that we've done in episode 2. Uh, don't forget those, right? So this file is provided, but you cannot use it as is. You need to go and configure the different values that you configured in episode 2 before you can move forward. And in this episode, I showed you the extra values that you can configure, for running a multi namespace setup. So we're gonna run this very quickly, and it shouldn't take a lot of time for the Action Runner controller to update or upgrade to the new configuration. And you can see here that we are good to go on that side. And then the next thing we're going to do is we are going to install another controller, and I've created another values.yaml file. But before we do that, I want to show you what's in that values.yaml file. So if we do a quick vim actions runner controller alt namespace values.yaml, and I've created a new folder called alt namespace where I'm going to include this file. Sorry, I have an example file, so let me first copy it and make it a non-example. So actions runner controller alt namespace and then values.example. I'm going to remove that example from the end, and then we're going to edit the non-example file. Sorry, values.yaml. All right, great. So here you will see a few changes. First of all, instead of using the GitHub app configuration, right, I'm going to be using a GitHub token. And I'm going to be using GitHub token here because I want to show you another form of registering runners. And in this case, we're going to be doing enterprise runner registration, which can be installed and configured to operate across multiple organizations. So you install them once, and these runners will be available for multiple organizations that you can specify. And you can create runner groups that span across orgs, or you can add them to the default runner group, and it will be made available to all your organizations and repositories within these organizations, with the exception of public repositories, of course. And unfortunately, there is no way to install GitHub apps on the enterprise level yet. But that's why we need to use a GitHub token. You can see here it's redacted. I'm going to change that. I'm going to create a token right now, and I'm going to show you how you can create one and what are the privileges required. And we're going to update this value in a bit. The second thing we are going to do is we're going to, of course, make sure that our name overrides are different than the name overrides we used for the first namespace. And here we're going to choose Alt and S, and then Alt and S dash actions dash runner dash controller. Everything else stays the same, of course. Cluster IP for the service. This is the configuration we did in the episode 2. Then Everything else stays the same. Of course, single namespace needs to be true. Watch namespace needs to be Alt and S. And then, of course, um, the GitHub webhook secret token. This is also very important. And then, of course, the name override and the full name override need to be provided as the following, or you can provide them with whatever name that you want. And then, of course, the service for the webhook cluster IP as well. Ingress needs to be disabled because we're going to be using the API gateway as our Ingress controller. And that's basically it. Of course, you're free to change all the other values once you have a good grip or idea of what they are. For now, this is sufficient. Let's go create the personal access token. So I'm going to jump to another account right now, and I'm going to be using another organization, and this organization is called Beirut, and it's part of the Poison Inc. enterprise. So I'm going to, first of all, go to my profile, settings, and then I'm going to jump to developer settings, personal access token. And as you can see here, I've already created a personal access token. I don't know why I called it Inner Sanctum. It should be Beirut, but whatever. Let's add our password over here. And then you should land on this page. And the privileges that you need to provide for this token are as follows. So I think I gave it a little bit more than it needs to. So repo, yes. Workflow, not necessarily. Admin org, yes, you need to provide it. Admin repo hook, these are optional. And then the main one is enterprise or admin enterprise, right? Because it needs to register the self-hosted runners. And it's this one is, I don't think it's optional, it's required. Once you have this, I'm going to regenerate my token, and I'm going to give it a 7-day expiry period. I'm going to also expire it manually before that because now it's exposed. And then I'm going to edit my values.yaml file to include this token. So we're going to jump to the section over here, and we're going to change these values, and we're going to paste our new token. We're going to save the file, and now we are ready. So let's install our second controller in the second namespace, and it should be quite smooth as well. Fantastic. And how do we verify this? We can do a quick kubectl get pods -n alt and s. And as you can see here, we have our webhook server perfectly running. If you want to do a quick extra verification, we can look at the services, and you can see here that the service for the webhook is also running perfectly over here, the webhook server, which means that we are good to go. The next thing we're going to do is our enterprise configuration and our enterprise webhook configuration. But first, we need to also configure our Ingress controller, right? So for this, I have a couple of changes that I need to make. So first of all, let's have a quick look at the new multi-namespace Ingress configuration. Compare that with our latest Ingress with the latest Ingress configuration that we deployed, which is ingress tls-runners.yaml. And you can see here that I've just introduced a couple of small changes to the paths. So in the default, we had /runners-scalar. And now I want to create a distinction, right? Because I'm going to be introducing different rules, and I'm going to have different namespaces. I would want to understand from the path, from the URL, right, this webhook belongs to which namespace. And it's probably a good practice. So instead of having something as generic as runners controller, now I'm going to be using / the namespace and then /runners scalar. So in this case, it's going to be /default /runners scalar. And then the service, you need to make sure now, because we are using a name override, right? The name of the service obviously changes. So you need to put here the name of the service that belongs to your namespace. And with this is the initial change that we need to introduce. So let us do that. Let us apply this change in our default namespace first. We did not create the rule for our second namespace yet, right? And we can do that with the following file. I'm going to show you very quickly what's in it. And same exact configuration, right? Nothing changes. The spec, the rules, everything is the same. And this is the nice thing about the application gateway. If you apply multiple rules to different namespaces, it will not create another controller. It will not create another application gateway. It will just simply create a new rule in the same application gateway instance from across namespaces. And this is how you do it. Just make sure that the annotations are proper, as you can see here. and then you can just specify the new path. And in this case, it's going to be alt ns dash runners scalar. And of course, we're going to be pointing to the service in the second namespace. And deploying this is as easy as just applying the configuration file in the correct namespace, right? Please make sure you specify the namespace alt ns. And when we do that, we can have a quick check on the ingresses to make sure that all our configuration is correct. So we can do kubectl get ingress dash main, first of all, in the default namespace. And you can see here that our ingress is working. So let's describe it this time. And we can see here that we have / default. That's looking good. We have the test app that's already running. That's great. We're going to do a couple of curl commands right now to do a quick check. And then we are going to now do a description on the ingress main, but this time in the alt ns namespace. And we can see that the path is properly configured and it's pointing to the appropriate service. And I really don't expect any problems over here. So let us do a quick sanity check by doing some curl commands. So we're gonna run curl-g and then http /default /runner scalar, or is it runners? Yes, we get the proper response. And then this time, let us change the default to alt ns. And we see here that we also get the appropriate response. And for extra, for extra checks, we can go to our, of course, our application gateway. We can refresh this and we can have a look at the listeners, and we should be able, oops, sorry, we can go look at the backend pool, and we should be able to see the three configurations over here. So we have the alt ns GitHub webhook server, and we have the default GitHub webhook server. And this looks really good. This is exactly what we want. And now we need to configure the, the hooks on the enterprise level for our Poison Inc. enterprise. So I'm going to jump to my GitHub, and I'm going to go to my org, which is called Beirut org. And then from here, I'm going to jump to my enterprise. And from here, I'm going to go to settings, hooks. And here I can configure my, webhooks. Of course, you can see that I've already, configured one for testing. So we're going to delete this and we're going to configure a new one. We're going to click on add webhook. And then we're going to provide the URL over here, which in this case is going to be HTTP. I have some problems with my TLS. That's why I'm not using it, but you need to use TLS, of course, because it protects your payloads. You're sending sensitive stuff here. And then alt ns / runners scalar, right? This is the URL. And then we need to change the content type. We're going to provide the secret. And where do we get it from? We get it from our, YAML file. So we're going to run the following. Alt ns, and then we have the values.yaml file, and of course the webhook secret is provided in the webhook section, which is going to copy it, or better yet, you need to change it to something much more secure than this. So I'm going to copy this, I'm going to put it here, and now instead of send me everything, don't do that because it will overload your cluster or your webhook server. We're going to select the workflow jobs and workflow runs, and we're going to click on add webhook. Once we do that, we can click on this one more time to see the events, and you should see the first payload delivered successfully. If you don't see this as a success, that means you have a problem with your configuration, because the webhook server should respond with the appropriate message to this ping request. And now that we see this configuration done correctly, we are ready to utilize, to create a new deployment that will create enterprise runners. But before we do that, we need to do one more thing on the enterprise level, which is to configure a little bit our policies, and then go to actions. And we need to do one thing on the runner group level. So on the runner groups, we have the default group that is created or that is available by default or off the shelf. And this default group, we need to make sure that it is accessible by all organizations. So this is very important. When you add enterprise runners, you need to make sure that these runners can be accessed by organizations. And you can control this by creating either new runner groups that you customize whichever way you want. And the action runner controller does not create runner groups for you. You need to create them manually or through the API first, and then you can add runners to them. By default, we're going to use this one, and you're going to change the organization access to all organizations, or specify a small set of organizations that you'd like to allow to provide access to these runners that we're going to be creating right now. This is very important, right? And then the next thing you're going to do is on the organization level. So I'm going to switch back to my Beirut organization. This one, we're going to go to settings, and you also need to change in the actions section. If you go to uh, runners group or runner groups, you need to make sure that the default runner group over here or is allowed or is accessible by all the repositories. If you don't do these two steps, you most likely will send the webhook events, but the runners are not going to be created and they're not going to be provisioned for your workflows, or even the webhook events are not going to, the workflows that you create in the repositories are not going to run. So these changes are necessary, and once you do them, we can jump to our test repository in the Beirut org. Sorry, before we do this, we need to install the deployment, right? So let's jump back to our terminal. And let us deploy our enterprise runner deployment. How does this deployment look like? If we do a quick cat on this alt namespace and autoscale webhook.yaml file, you can see here that nothing really has changed. However, first of all, the namespace is alt ns. And then the second thing is I changed in the spec, instead of organization, I'm specifying the enterprise name right now, which is Poison Inc. And then I'm providing labels. They're the same labels. Nothing really has changed. And then also in the horizontal runner autoscaler, I am changing the namespace. That's it. That's all you got to do. And then you can just simply execute this deployment. And when all of this is created, we can do a quick sanity check. Also get pods-n alt ns. And yeah, we should see this in our alternative namespace provisioned. And now we are ready to do some trial runs. So if I come to this workflow and I pick single job, I just added one workflow here. We're probably not going to need more than that. It's going to scale and behave in exactly the same way. And we're going to trigger this workflow run over here. And now we're going to, show you a quick verification of what's going on. So watch-n2, you should be able to see that we're going to have a new runner that will be provisioned in a bit. Let's put this over here. The first time it takes a little bit of time because it needs to pull the images and whatnot, right? If the images are not available, it might take a little bit of time, but otherwise the runners should be hot and available. And as you can see here, the runner has been added, and I think the job has been completed successfully. No, not yet. Let's see. It's still queued. Oh, it's running. That's great. And you can see here that it has probably completed the one-line script, and now it is running the multi-line script. I have a sleep command in it. So once this is run, the workflow or the job should be completed. But already this is a good indication that our trial has worked in Beirut org using enterprise runners. And that's it. That's all I wanted to show you. The last thing I want to do before we wrap up is I want to nuke this whole setup. And this is the fun part of using the cloud. With one command, I can delete the entire resource group, as well as all the configuration that is in it. And then everything is going to be back to where we started. This is everything I wanted to show you. Let's jump back to the slides. If you have stuck up with me so far, you are the true heroes. Really, like through 3 episodes, we have gone through so much information, so much configuration, so much setup, that it is mind-blowing if you were able to keep up with all of this that's been going on. Of course, if you have prior Kubernetes experience, this is all too familiar for you. Nothing here is out of the ordinary. And now I'm gonna jump back to answer your questions live. Thank you very much for watching. Wow, this has been a very nice series that spanned across 3 weeks. I'm very happy that we've come to the conclusion of it. I really hope that you got the most out of these sessions and that the demonstrations were useful to you. I hope you were able to pick up new information, new insights, new knowledge. Of course, this part of the episode is dedicated for your questions, so feel free to drop them in the chat and I will do my best to answer them. I just want to mention also that I really love and appreciate your feedback. It has been amazing. Thank you very much for your honesty and for the your kindness and your kind words. I'm really happy that you were able to get some value out of these episodes. I also want to thank some of you who have contributed fixes and changes and enhancements to the repository that contains the instructions. Thank you very much for those. Of course, contributions from anyone are welcome. This is an open source repository. It's made for you. So if you spot any problems while you're doing the setup, or if you think that there's a better way of explaining or providing certain instructions, please do create a pull request and I will do my best to review it and merge it as soon as I can. One last thing I want to mention before we wrap up, if there are no more questions, we at the Expert Services would love to take on, your questions and support you. My colleagues in the solution engineering team also would love to help you, set this up and also make it available for you in your own organizations. The action runner controller is not the only way that you can scale actions in the enterprise and specifically self-hosted runners in the enterprise. We do have another solution which is not made public yet. It's called Elastic Machines, which allows us to have auto scaling, but for VM-based runners. And of course, anyone who is any enterprise organization that is deploying, that is doing intensive CI/CD work, or you're doing stuff beyond just simple automation, you're definitely going to require beefier, bigger VMs. So also, this is a service that can be provided via Expert Services. Please make sure you reach out to us. The feedback form is now in the comment section. I would really love your feedback on all of these episodes, and please do make sure to reach out to us for further instructions, further information, to share with you certain best practices and knowledge that we have picked up from the field. If there are no questions for me, I'm gonna wrap up this series. Definitely tell us what you would like to see in the future. I would love to come back with more, demos or instructions, or sharing with you just best practices. So please do let us know what you would like to see and we will make it happen for you. Until then, I want to wish you a great rest of the day. Enjoy your weekend. My name is Basim and I will see you next time.